In this lesson, we're going to look at reference angles, exact values of trigonometric functions in other quadrants. So those are the two topics that we're going to look at. So the first thing we're going to do is we're going to sketch an angle in standard position. For standard position, we need the initial ray of the angle, or the initial side of the angle, to be pointing towards the positive x-axis, like this. And then the terminal, or the ending side array of the angle, to be drawn, 90-degree angle would be drawn up like this. So that would be a 90-degree angle in what? Standard position. So let's draw a 180-degree angle. So first I'm going to draw this piece, and then I'm going to draw it this way. So that's 180 degrees. So this is 90 degrees up here, 180 over here. Good. Now how about 270? 270 is called a reflex angle. So first I'm going to go here, and then up and around, that would hit 90, this would hit 180, this would be 270. So that's how I would draw the angle 270 degrees. And last but not least, 360 degrees is just bloop, right there, because when I go all the way around again, I've gone 360 degrees. Perfect. Let's do ones that aren't right on the axis line. Let's do a 30-degree angle. Again, we're going to go foomp on the positive x-axis, and then 30 degrees is up about like that. So that would be 30 degrees. Good, and it's in quadrant 1. What does it mean by in quadrant 1? That means the terminal side of the angle, or the terminal ray of the angle, ends in quadrant 1. When we're talking about doing positive angles, we're always going in a counterclockwise direction from the positive x-axis. When we talk about negative angle, we're going to measure from the positive x-axis in a clockwise direction. So negative 30, we'd go bloop. That would be negative 30 degrees, and that would end up in quadrant 4. Oh, again, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, in case you forgot. Okay, 200 degrees. Well, I'm going to start from the positive x-axis. If I go up here, that's 90, 180, and then a little bit over, that would be 200 degrees, and that's in quadrant 3. And how about 380 degrees? Well, I start by drawing my little bloop, and then I go around 90, 180, 270, 360, and then a little bit more would be approximately 380 degrees, and that's again in quadrant 1. So far, so good, right? Not bad. Now, let's talk coterminal angles. So, let's talk coterminal angles. A coterminal angle shares its terminal side with the original angle. So all you have to do is add or subtract 360 degrees. If we want a positive coterminal angle, depending on where the angle is, we're just going to add 360 degrees to 65, and we get a positive 425 degrees. And then if I add another 360, I'll get another 785 degrees. And those are both positive, and the terminal side of the angle will end where 65 degrees is. If I want a negative, all I have to do is take 65 and subtract 360. And you're like, this is like heaven, isn't it? So negative 295. Erase that 9. Good? So I add 360. For another one, I can add 360 again, 2 of them. Subtract the other one, I just take my angle minus 360 degrees. Good? Now the other one I'm doing starting with negative 40, and I'm going to add 360 to it, and that gives me 320 degrees. And then I add another 360, I'll get 680. Good? And then I start off with negative 40, and I'll subtract 360, and I'll get negative 400. Cool? So for this one, I start with negative 40, and I add 360. That gives me this. This one, I start with negative 40, add 360, add another 360. That's how I got this guy. This guy, I start with negative 40, and I subtract 360, and that's how I get that guy. Beautiful. Okay, so let's talk reference angles. First thing we're going to do is sketch the angle in standard position. So here I go, 50 degrees is about, I guess about here. So then what I want to do is figure out how many degrees it takes for me to get back to the x-axis in the shortest number of degrees, or the smallest number of degrees. So, boom, 50 degrees. So the reference angle for 50 degrees is itself. In fact, all angles in the first quadrant that go from between 0 and 90 degrees will be their own reference angle. All right, so let's draw a 100-degree angle. First, we draw it in standard position, and that's about 100 degrees. Well, not really. Let me make it a little better here. That's better. Okay, that's about 100 degrees. And we need to get back to the x-axis the shortest way. Well, the shortest way is right here. So how many degrees would that be? Well, to get from 100 to 180, it's 80 degrees. And reference angles are always positive, and they're between 0 and 90 degrees. Good? Great. So if I have a second quadrant angle, all I have to do is do 180 minus the angle if it's in the second quadrant. Cool? Yay! Okay. Now let's draw this next one, 200 degrees. Well, that's 90, 180, a little over. Good, so that's 200 degrees. I have to get back to the x-axis in the shortest way possible. So here it is right here, and how many degrees do I get to get back to the x-axis? Yes, 20 degrees. Good. So if I'm in the third quadrant, it's the angle minus 180. But I prefer to draw it so I can see what's going on. And last but not least, let's draw negative 120. So that's going to go clockwise, 90, 30 more degrees. There we go. That's negative 120. Good. And boom, I have to get back to the x-axis in the shortest way possible. Boom, boom. I really need to get to, if I do that, I'm getting back to negative 180, which is like regular 180. So you can see that there's a 60-degree difference there. Cool? Super great? Fantastic? Great. Now, y'all remember your 30, 60, 90 triangles and 45, 45, 90 triangles, and these are all our trig functions associated with those angles. Yay! Okay, filled it all in. And now we're going to use that information to help us do some examples. Okay, it looks complicated, but if you follow the steps, you're going to be golden. So first, we're going to find the reference angle for 210 and then get the sine of 210. Cool? So first we're going to draw 210. Okay, here's 210. Get the reference angle. I need to go back to the what axis? You got it, the x-axis. So that's going to be 30 degrees to get back the shortest way to the x-axis. For the original 210-degree angle, we're going to draw a point on its terminal side. So I'm going to do a little bit of erasing so we can get a nice clean picture of this. And then we're going to draw a vertical line right to that point. So we're going to make a little cute triangle, okay? The triangle is in quadrant 3, agreed? There he is. He's adorable. We love him. Okay? So now what we're going to do is we're going to label the reference angle in the triangle. And we discovered the reference angle is 30 degrees. Good? And y'all remember that 1, 2, square root of 3 on that triangle, right? Cool? So we're going to use the reference angle. The sine of 30 degrees is opposite over hypotenuse, so that's 1/2. Okay? So now let's go back to the 210. Okay? Since it's in quadrant 3, okay, we're going to label our sides. Which one, either the 1 or the 2, will be negative? It's going to be the 1 because I'm going down 1. Actually, the square root of 3, which we don't need for this problem, is also negative, but the hypotenuse of these triangles is never negative. So the sine of 210 will be negative 1 over 2. Okay, cool? Cool beans. Let's try another one because I know it takes a few to really get this. Okay, we're going to find the reference angle and get the exact function value for the tangent of negative 120. So first we're going to draw negative 120, right? And then we draw a triangle. The reference angle is, how do I get back to 180? It takes me 60 more degrees, so this is 60 degrees. So if we do the 60-degree thing, this is going to be 2 square root of 3 and 1 here. Cool beans. Now, both of these values, the 1, because I'm going left 1 and down down square root of 3, both of those values will be negative. And tangent is opposite over adjacent, right? So my opposite would be negative square root of 3, and my adjacent is negative 1. So my tangent of negative 120 is square root of 3. Yay! Okay, next. Okay, let's do another example here. Let's find the cosine of theta, where theta is an angle with the terminal side through the point 7, negative 24. So 7, negative 24. I'm just ballparking it, you guys. So here's my theta. Fantastic. And this is a right triangle. So all I really have to do is figure out the hypotenuse of this, and blammo, I can get the cosine of theta. Because it's adjacent over hypotenuse. Well, we already know what the adjacent side is. It's 7. The hypotenuse we don't know, but lucky for us, we know the Pythagorean theorem. So 7 squared plus negative 24 quantity squared equals c squared. 7 squared is 49. Negative 24 quantity squared is 576. Good. So we get 625 is equal to c squared. Take the square root of both sides, so c is equal to 25. There he is. There's my cute little adorable hypotenuse. So 7/25 is the cosine of theta. Do we care what theta is right now? No, we don't. Next, let's look at this one. We are going to find the cosine and the cotangent. For if the sine of theta is -12/13 and theta is in quadrant 3. So first we're going to draw theta in quadrant 3. Okay, that whole thing is theta, but here's my reference angle here. That whole thing is theta, but that's my reference angle, which I can use to label my diagram. Sine is opposite over hypotenuse. How did I get the 12 and the 13? Well, I used that ratio, but the 12 is not positive. Oh, no, 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 because we're going down 12. So it's negative. Hence, that's why the sign in front is negative. And now, lucky, 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 lucky us, we know Pythagoras well enough to know that we can find the length of the side. We just have to make a sign adjustment because it's going to be negative because I'm going left, right? So a squared plus b squared is equal to c squared. A squared plus -12 squared equals 13 squared. So a squared plus 144 equals 169. A squared equals 25. A equals 5, but we need to make a sign adjustment because we're going left with that triangle because that triangle is there. And now we get it. Cosine of theta is adjacent over hypotenuse, right? Yay, adjacent over hypotenuse. Good. Cotangent is adjacent over opposite. So -5 over -12, but we never write negative over negative. That's just totes positive, right? Good. And now I'm just going to do one more thing before I end this lecture. Okay. If I look at this, and it's my coordinate axes, but this is like a big fat positive sign, right? All trig functions are positive in the first quadrant. Sine and cosecant are positive in the second quadrant. So A, S, T, tangent, cotangent are positive in the third quadrant. And cosine and secant are positive in the fourth quadrant. All students take classes. Yay! Okay, go for this assignment, rock on, and do the math.